Alright, in the last video we talked about functions and what the anatomy of a function is, and did a couple examples. We also talked about conditional branching, so how to use if statements and if else statements, and also stringing together if else statements. And just to kind of review those, show you this here. So this is just the basic if statement, and we also talked about Boolean expressions, where we do a comparison that evaluates to either true or false. So this greater than and then the equal sign following is called a Boolean operator or a logical operator, and it evaluates to a Boolean value of either true or false. Okay, so here's the if else. You notice that these always have the end keyword. So this says if this evaluates to true, then it's going to execute these statements. Otherwise, or these commands, we can put commands in between the if and the end. This one says if this expression evaluates to the Boolean value of true, then execute these commands. If it evaluates to false, execute these commands here. So remember, MATLAB's case sensitive, and then you can string together these if-else statements by using this else if you want to check multiple conditions, and have different commands to execute based on those conditions. So that's just a little bit of review of what we covered last time. This time, what we're going to cover is how to write little one-line functions in a very quick way using function handles, and then we're also going to go over looping control structures, which allow us to perform a set of commands that need to be repeated frequently for any number of times. So first let's talk about how to define just function handles. So let's say I have just a simple function like 14 times x plus 3, so maybe a polynomial, and that is equal to f of x. Well, I can make this a function. If I just hit enter, it's going to say, hey, you have an undefined variable x, and then there's also no way, if I typed f of x equals 14 x plus 3, here I need a multiplication operator, this doesn't work. It doesn't allow me to define a function like that. But if I use this special syntax, if I put the @ symbol in between the name of the function and the argument list, then it works. Oh, how I messed this up. Hold on. Let me figure out what I did wrong. Oh, sorry. I put the it's got to be like this. The syntax is like this. Let me clear this for you. So let's clear all our variables there. So you got to say the name of the function. So I'm just going to name the function f. It's going to be equal to @ then the arguments list. Now I can type in the function 14 times x plus 3. And now you'll see this little function handle has popped up over here in my workspace. So now I can type f of 3, and it'll evaluate that function and return the value. So For functions that are just one equation, you need one line to define them, this is a really handy and easy way to define functions. You can also pass function handles defined in this way. So this is a function handle definition. Once I've defined it, I can now pass this function to another function. So let me illustrate that real quick. So if I create a new function, and I'm just going to call this test, and I'm going to pass it an x value, and I'm also going to pass it some function f. I'm going to have it return a variable named y. So I'm going to just say y is equal to some polynomial. Let's use 14 times x plus 3. But I'm also going to have it add on whatever function I pass it to evaluated at x. Alright, now I can save this. Saving in this tutorials folder, which is where I'm working. And I can go back to my workspace here, and I can type in test. I can pass a value to it. I passed in 3.0, and now, looks like test is all a predefined function in MATLAB. Help test. I think it is. Let me delete this real quick and check. Now let's try it. Help test. Yes. Okay. So MATLAB has its own test function, compute error rate for tree. So don't want to name my function test. So let's rewrite that function. Give it a different name. Alright. So there, I had it return y. Instead of naming it test, we'll call it embedded function, because we're embedding one function inside of another, kind of. So x comma f, y equals 14 times x plus 3 plus f evaluated at x. Alright, there we go. Save this. Now I'll go back to the command window. Alright, so I'm going to define a new function handle. I'm going to call it square me, or square it. That's going to be equal to at x, and it's going to be x squared. Okay, so now I can take and I can square any number using this function that I defined using a function handle. If I type in 2, it'll give me 4. If I type in 4, it'll give me 16, etc. Okay, now let's try our embedded function. So if I type in embedded function, and it's going to take an x value, so I'm going to give it an x value of 2, and then I'm going to pass in this function called square it that I defined as the function handle. So now when I do this, I get an answer of 35. So how did we come up with an answer of 35? Well, we go back and look at our function. Remember, we passed in square it, so this function now becomes square it. So, and I passed in 2 for x, so this is 14 times 2, which is 28, plus 3 is 31, plus square it, evaluated at whatever x was. Remember, we passed in 2 for x, so that's 4. So 28, right? Plus 3, 31. Plus 4, 35. Now I could pass in a different function if I wanted to. I could define another function handle here. Maybe I'll call it square root it, where I'll take the square root. This is going to equal at x the square root of x. Okay, so this function that I defined called root it just takes the square root. So I can type in root it of 4 and it'll return 2. Or root it of 16 and it'll return 4. The cool thing is now I can call my embedded function. Instead of passing it square it, I can pass it root it. Now, instead of using the square it function in this function, it uses the root it function. So 31 plus the square root of 2 is 32.4142. Anyways, there you go. So that's a handy way to define short little one-line functions, and then we can actually pass functions to other functions. Now, I can even pass functions that I've defined in a function file to another function if it asks for a function handle as an input. And when I do that, let's just write another function real quick here to demonstrate just a simple function. I'm going to do new function, and this one I'm going to title y, so it's going to return a variable defined y. I'm going to call it qubit, and it's going to take an x value, and all it's going to be is y is equal to x cubed. Okay, now I'm going to save it. Now, go back to my MATLAB command window, and I can use my embedded function and pass it a value. So maybe I'll pass it 2 again. Instead of passing it one of these function handles that I defined, like root it or square it, I'm going to pass it the qubit function, and to do this I have to put an @ symbol after this. At least I believe. Oh wait, maybe it's before. I can't. Sometimes I forget. There. Yeah, you just have to put the @ symbol before qubit. If you didn't, if I left this out, I think it yelled at me. Yeah, it says not enough input arguments. So when you define functions in a file, not as a function handle in the command window, when you want to pass them to another function, you have to put the @ symbol before. This says, hey, I'm passing in a function named qubit, and it's defined in this file over here. Okay. Anyways, there we go. Let's clear the screen here. Alright, so that's how we define function handles and pass functions to functions. Now I want to talk about looping structures. So let's say that I have some function, f, I defined f as this function handle, which is just a polynomial, a linear polynomial, 14x plus 3. Let's say I wanted to evaluate this polynomial or any function at several different x values, maybe 1,000 different x values, and say they're equally spaced. Well, maybe one way I could do that is I could start out and I could say, alright, let's create the first x value that we want to pass into, and I'm going to call that 0. And now, actually, let's do it like this. Let's just say the value of x we want to, I'm testing something clear, x1. Yeah, okay, good. Alright, so let's just say we're going to store the current value that we want to calculate our function value as xi. So let's just say, hey, we want to evaluate the function at 0 first. Okay? And now we want to calculate equally spaced values. So now, just for example, I could evaluate the function at xi, and it's going to return a value for me. Now, let's say I wanted to increment and change xi to be equal to what it was before, plus some distance h. I haven't defined h yet, so let's say h is equal to 1. So I want to take steps of 1 in x and evaluate my function. So now I could say xi is equal to xi plus h. So now xi is equal to 1. Well, now I could evaluate my function at xi, and it gives me the value. Well, then I could increment this again. Now xi is equal to 2, because it was equal to 1 before. Now I'm setting equal to 2. Now I could evaluate f of xi, and so on. So now I'm generating kind of a whole series of numbers of both x values and function values using two commands. Xi equals xi plus h, and then evaluating the function at f of xi. Well, the handy, wouldn't it be nice if we could just kind of automate this process and generate maybe a set of 10,000 xi values and corresponding f of xi values, and maybe we change h to be a much smaller spacing so we could generate a whole bunch of x values and their corresponding function values in some range, say between 0 and 10. I want to generate 1,000 x values and corresponding function values. Well, this is where looping structures come in. So whenever you want to repeat some command a certain number of times, you can use what's called a for loop. So the syntax for a for loop is very simple. I'm going to show you here real quick. So this is the syntax for a for loop. Now I, right here, is what's known as the loop index variable. So it is a variable that gets defined once you jump into this loop. So what this says is let's let I start at a value of 1 and then go in steps of 1 all the way up to 10. And you're going to, each time I is given a number, execute all the commands in here inside this for loop. So any statements like this, x equals xi plus 1 is one such MATLAB command. And execute all the statements till you get to this end command, and then come back up here and increase the value of I by 1 increment. So it'll go to 2, and then execute these commands again and increment I to the value of 3, then execute these commands again, then 4, execute these commands again, and so on till it gets to 10, and then it'll be done, and it'll continue on whatever other commands you have below the for loop. So the other thing that you can do is you can change by how much it increments by putting 2 semicolons, and in between you put how much you want it to increment by. So this one would increment by a value of 2 instead of 1. So let's go ahead and kind of demo this so you can see how it works. Alright, let's clear our command window, and I'm going to just write a little script to demonstrate this. So in this script, I'm just going to call it looping example, and I'm going to define a for loop. For I equals 1, 2, 10. And all I'm going to have it do, so I'm going to type the n. So for loops always start with the for keyword and end with the n keyword. You always have to define an index variable. This can be I, it could be anything, it could be J, it could be Harry, whatever you want to name the indexing variable. It's very common to use I or J or N or K or something like that. Those are common just variable names that programmers use for looping indices. Alright, so all I'm going to do here is I'm going to say, hey, MATLAB, print out, tell me what the value of I is. So I'm going to type in I. I'm not going to put a semicolon after it because then it'll print out to the screen. So I'm going to save this script as looper. Oh, that's weird. I don't think it liked that name. Let's try changing the name. I wonder if I can do that in the command window. I wonder if I can come over here. Yeah, I didn't like that. Let's rename this to be loop.m. See, did it change in my script over here? Yeah, okay, now it's looking better. Okay. I wonder if looper is a MATLAB function. Oh, looper. Oh, nope. Loop. Alright. Well, now if I run this little script, it should just run the commands in that script, which is that for loop. So if I just type loop, we see some output. So here's the output. So loop, all it did was it jumped into that for loop and it says, okay, I is equal to 1. We don't have any other commands in there, so then it jumps and it iterates I, and now I is equal to 2, then 3, then 4, all the way up to a value of 10. Cool. So how can we use this to generate a whole bunch of x values and a whole bunch of corresponding function values associated with those x values? I'm going to show you how you could do that. So I'm going to go back into this looping script and modify it. So let's just say we could set xi. One way we could do it would be to just set xi equal to I. And then we could set fi, which this stands for f evaluated at xi, so maybe we should just say fxi is going to be equal to our function evaluated at xi. Now I'm going to take the semicolons off here so we can see the output of this command. I'm actually going to make it only go from 1 to 3 for now. So let's save it and go back and run it. Alright, let's run loop again. Alright, so our function f is defined as this function handle still, so that's 14x plus 3. And now we see it set xi equal to 1, and then f of xi got calculated as 17, which is just 14 times 1 plus 3. That's 17. Now xi next gets incremented to a value of 2, and f of xi gets set to our function evaluated at 2, which just so happens to be 31. 14 times 2 is 28, plus 3 is 31. And then finally we get xi is set to I, the I value, which is now 3, and then evaluated at, and then our function is evaluated at that point to give a value of 45 for fxi. So you can see, hey, we can generate a whole bunch of function values. And in fact, we can do a ton. We can go back to our thing here, and let's say we wanted to do 3,000 or 300. Let's just do 300. Save it. Oh, whoops. Sorry. There we go. If I run loop, now look. It generated tons and tons and tons, 300 to be exact, x values and function points. So, now all the x values are just being set to I. So one way that you can change how much it's incremented by, like I said before, is I can come back here and I could say, instead of using a step size of 1, use a step size of 0.001. So now it should go x values between 1 and, ooh, let's make this 0. So between 0 and 3 in steps of 0.1. So save this, run it again, and you'll see what we get. Oh, hold on. So if MATLAB's ever freaking out and taking forever to run a command you run, you can hit Control-C and it'll terminate your loop. So what's happening is this loop is now going, instead of starting at 0, and it's going to a value of 300 in steps of 0.1. What I wanted it to go was just to a value of 3. So this will print out 300. So if I save this, it was doing, well, 1,000 steps per each unit times 300, so it was doing 300,000 calculations. So I want to keep hitting that button. My bad. Alright. Here we go. Put a command window, hit loop. There we go. Now it just did 300 and evaluated them at different points. Anyways, it's actually good habit to just get used to using loop indexes that loop in increments of integer values, so just 1, 2, 3, 4, 0, 1, 2, 3, 4, etc. Because in other programming languages that is common, that is what is typically used. And so if you want to get a finer spacing between your x values, you can actually just calculate it. Let me show you here. So you could just calculate a variable. So you could say xi is equal to some starting value, call it 0, plus I times h. And now, and we can get rid of this, 0 to 300, and now we can set h equal to something. H equals 0.001, and this should give us the same thing that we had before. So if I save that and then run it, should get the same thing. Well, it went out to xi equals 0.3. So actually I needed to do 3,000 of them. My bad, not 300 of them. 3,000. Now it'll go out to the same. There we go. Alright, well that's all I'm going to do in this video today. tomorrow I'm going to show you how you can use looping structures to do a simple, not tomorrow, in the next video I'm going to show you how to use looping structures to do an integration example. Show you how you can use a Riemann sum, calculate a Riemann sum with a for loop to approximate an integral. So it'll look something like that. To do a problem something like this. These axes should be down here. Anyways, until next time, we will see you then.